viewers. Again, this is Mr. Odingo coming with chemistry. I want to be able to explain to you today what we mean by diffusion. And I want you to pay attention because we have talked about matter, and diffusion is still talking about particles of matter moving. So it's a very key point. We are still in the same chapter, and I want us to try to move faster to finish this chapter and be able to understand now if particles of matter doing, how does it happen in the real life situation. And without wasting our time, I want to explain what matter is. And before I explain or define, state what diffusion means, I want to invite you to your environment. Your environment, things we use every day. For example, perfumes. Most of men, ladies use perfume. Perfumes, we use them because they smell nicely. And we can always smell perfumes from different people, different places. We can smell bad things as well. For example, a dead animal rotting somewhere, that can produce a bad smell. The question is, how does that smell reach us? That's what diffusion is going to try to explain for us today. That bad smell we talk about, how does it reach us? Now that bad smell or that nice smell of a nice food being cooked in the neighborhood is coming to us or reaching you wherever you are by the process called diffusion. So those are just natural examples of diffusion in action. Today I want us to go deeper to understand scientifically what diffusion is. And I will say that diffusion is the movement. Diffusion is the movement of particles. Diffusion is the movement, let me use the word net movement, net movement of particles, net movement of particles from a region of their high concentration, to a region of low concentration. That is what diffusion means. It means that particles will always move from where there are more to where there are few. That is what happens. Even human beings, people migrate from where there are more to where there are few to get space. So particles also will move from where there are more. So when you smell perfume somewhere, know where you are smelling it from is less. It's coming from somewhere where it is more, and you can always follow. As you move closer to the source, the concentration of the smell will increase because you are approaching the source of that particular smell. So we are going to look at two ways of explaining diffusion. Diffusion can be explained in chemistry in two ways. One, we can talk about diffusion in liquids. Diffusion in liquids, and then two, diffusion in gases. And today I want to specifically explain to you what we mean or how to understand diffusion in liquids. So I want you to pay attention as I explain to you diffusion in liquids. And in liquids, when we do diffusion in liquids, it comes to different things. For example, when we dissolve sugar in water, when we dissolve salt in soup, in our food that we eat at home, we are talking about diffusion in liquid because we are taking a salt, a solid, and we are ensuring we put it in a liquid and then we expect that it's dissolved. And many times you can always want to see, yes, diffusion will still take place. You normally at home we use a spoon to stir, or sometimes we heat, and we can always look at how do we ensure that particles dissolve easily or faster in liquids or in water. We can use heat, we can heat that solution, particles will move faster because again we go back to kinetic theory of matter. When kinetic energy is increased, particles move faster. So that's the same thing. When particles are increased, the kinetic energy is increased by heating the substance, particles will move faster and diffusion will move faster because we have defined diffusion as movement. So movement, we say particles move faster when there's more kinetic energy. If you don't want to heat, you can stir. When you stir, you are causing the particles to move faster. And as you cause particles to move faster, you are also achieving one goal, to make particles dissolve quickly or to make diffusion take place fast. There's another third point that you can use. Try to make the particles of the solid you are dissolving smaller. For example, if you have large lumps of sugar particles, you may want to crush them fast into small pieces to increase their surface area. That will also enhance the rate at which it dissolves. But that one will come to a later chapter called rates of reaction. We are going to discuss about how to ensure particles react faster. Today, we want to concentrate on two. And in this lesson, we are going to give you 2 points to increase the rate of diffusion of liquids. You can stir, or you can heat, or you can do both if you want to achieve the result faster. Now, in liquids here, I want to sketch a beaker. In this beaker here, we have water. And we know water is colorless. We have water there. And we have to carefully lower. A crystal of any salt. And today I want to use a colored salt. The reason why it's very important to use a colored salt here is because a colored salt is visible. So as it dissolves, you are able to see how color changes in every part of that beaker. So if I use sugar or I use salt, we will be forced to test because we cannot see the color. But testing, again, is not allowed in chemistry. No one is allowed to test any substance, even if you know what it is. So testing should be out, and that's why we need to use colored substances. Some of the colored substances we can use include what we call potassium manganese 7, which is purple in color. We can use potassium dichromate 6, which is orange in color. We can use copper 2 sulfate, hydrated copper 2 sulfate, which is blue in color. And there are many other substances that we can use. But in exams or wherever, or when you want to try this experiment at home or in the school, you need to try to use a colored substance because then seeing what is happening will be easy. So when we put these solids in water here, the solids here, I'm trying to say, let me shade them to show that they are actually purple, although they are not purple. They are purple, let me assuming I'm using potassium manganese 7. So these ones are potassium manganate 7. I've said potassium manganate 7, they are purple in color. So as it dissolves, we see the purple color moving until it reaches the top. At the beginning, the top of this water, this is water. At the beginning, the water is colorless with only purple crystals at the bottom. But as you leave it there, after some time, you'll see the purple color spreading from this region. After maybe 30 minutes or so, you'll find the entire water will be purple in color. Why does that happen? We come back and still use this point diffusion to explain. And we are going to use purple, the concept of diffusion to explain, but not diffusion only. We have to go back to kinetic theory of matter. About particles moving. And when these particles are moving, we have agreed that the particles in liquid state, the particles are closer to each other. They cannot just move freely. As they move, they'll be colliding against other particles of water. Other particles of water plus the wall of the container. So there are 3 things that are colliding here. 1, the particles of potassium manganate 7. Number 2, the particles of water. And finally, the wall of the container. These particles keep on colliding against each other. And we said that the movement is random. That is why we don't expect this purple color to come straight up here. The movement will be slowly. Why? Because these particles don't move in a straight line. They keep on moving randomly, different directions, and that one makes the movement of this color or the manganese 7 become very slow. Now, sometimes a student can be asked to state the observation that you can make when you do this experiment. 1, on the crystals of potassium manganate 7. Number 2, on the water. On the crystals, we know that when you are dissolving crystals in water, especially the large ones like the one I've drawn here, they start dissolving at the edges. Why? Because the edges have large surface area. So they start dissolving. As they dissolve the edges, the crystals become more round, more smoother as the size reduces. So we can talk about that the particle, one observation is that the crystals will become smoother, smaller, and finally they will disappear. Where do they go to? They are dissolving in the water. What will happen to the water? Another observation you'll make on the water is that water will turn color from colorless to purple. That's one observation you'll make. So you have two observations, on the crystals and on the water. Now, as this one dissolves, the water becomes more purple. So we cannot say that these things are disappearing like they're disappearing somewhere, but the solids are changing from solid and becoming part of the solution. So the color spreads until this part reaches here. Until the particles are evenly distributed. When the concentration of these particles here is the same as the particles up here, the diffusion will stop, because now the concentration is even, is equal. So we don't have what we call concentration gradient. We don't have one side which is more concentrated than another. So the diffusion will only take place as long as one side has more concentration than another. And that is why we say it will spread going upwards, because this part here we have less, we don't have potassium -7 completely, but the concentration is a lot here. Viewers, I've explained very many things, and if you are keen enough, you'll be able to understand how diffusion in liquids take place. Welcome, and thank you very much.